Assalamualaikum warahmatullahi wabarakatuh. Dear students, this is an experiment, advanced level biology, the eighth experiment in the practical guide, determination of respiratory rate and respiratory quotient of germinating seeds. To perform this experiment, you need these materials and equipments. You need green gram seeds, a conical flask, a bent glass tube, a rubber stopper, a balance, a petri dish, a potassium hydroxide solution, a marker pen, a ruler, a small test tube or ignition tube, and Vaseline. In the beginning, you need to soak the green gram seeds in water for 24 hours. In your book, you have been mentioned 8 hours of soaking. Minimum 8 hours it should be soaked. The good germination level will be achieved if you soak it for 24 hours. But it should be a patient work. You have to wait for 24 hours. Thereafter, you have to remove the seed coat, the green color part, because the green color part can create an anaerobic environment around the embryo, and due to that anaerobic environment, anaerobic respiration could take place. So here we need to do aerobic respiration. Then you have to measure and take 25 grams of germinating seeds. The book is recommending to measure and take 25 grams of the germinating seeds altogether. Right. Now we are measuring it. Okay, 22 grams. A little more needed. So altogether you need to take 25 grams of germinating green gram seeds. Okay, now correctly 25 grams. Now we place this once inside the conical flask, and we will be placing a test tube containing potassium hydroxide solution inside this conical flask. That is potassium hydroxide solution. We place it inside and we will cover it with a cork outside, and the cork is applied with Vaseline. You can see Vaseline has been applied there. Vaseline will work as a sealer. It won't allow the materials to anything to leak out there, so we are applying Vaseline. And this tube, there's a center tube there, and it is connected to this U-shape uh, unit having colored water. In the beginning, you have to mark the levels of the colored water. The two levels will be same. Okay, two levels should be same. Then you can allow the changes to occur. You can see at the moment slightly the left side has raised and the right side has moved down. Okay, so the levels are changing. You can see when time goes up, the levels will be changing. Okay, so until it comes to a constant level, you have to continue, have to wait until it increase, and finally come to final level. Okay, it will show a considerable difference there. Show a considerable difference conformably. So you can see it has well gone down on the right side and well gone up. Only one thing, uh, the amount it has gone down and the amount it has gone up are equal. How much it has gone down, how much it has gone up, you can measure with a ruler. how many centimeters. You can see it's nearly around 1.3 centimeter like. Then we do the same thing without potassium hydroxide. Without potassium hydroxide, we repeat the same experiment, okay, and we can see no changes in the water level. Without potassium hydroxide, water level is not changing. Water level is not changing. So with potassium hydroxide, water level changes, that is H1. Without potassium hydroxide, water level doesn't change, that's H2 is 0. Second reading you get is 0, H2 is 0. Now this is the way we measure the respiration rate. The height H1, the height is representing the amount of oxygen absorbed. So to find out the volume of oxygen absorbed, we multiply the height H1 by the cross-sectional area of the U tube, and that is coming to you 0.3 cubic centimeter. So this is the volume of oxygen absorbed. Now we measure the rate of respiration by dividing the volume of oxygen absorbed by the mass and the time. Respiration rate or rate of respiration is measured as cubic centimeter per gram per minute in that unit. So this is how we determine the rate of respiration. If you consider respiratory quotient, you are familiar. Respiratory quotient is volume of CO2 released divided by volume of O2 absorbed. Here we use the height instead of volume because cross-sectional areas are same. So here we have two values, H1 value and H2 value. H1 is the representative value for volume of O2 absorbed. H1 minus H2 is the representative value of volume of CO2 released. As H2 is 0, now see volume of CO2 released is H1 minus H2, but H2 is 0. So volume of CO2 released is H1. So respiratory quotient is 1 because the mung beans or green gram is having carbohydrate as its respiratory substrate. Instead of mung beans, if you have used castor seeds, you will get a different value for respiratory quotient, which will be less than 1. So it will be a decimal value if you use castor seeds. Castor seeds are storing lipids in them. Okay, so hope you understood this particular experiment. Make clear the principles behind it with the contribution of your teacher. Good luck. Thank you.